The sea comes and goes, but the wind remains. Power is an inexhaustible source of energy, a natural form of energy for a secure future. For more efficient and higher energy yields, we require more productive plants and optimal wind conditions. These conditions already exist at sea. We can construct facilities here with the required dimensions and make use of the continuous sea winds. The future of wind energy lies offshore. The big challenge with the construction of multi-megawatt offshore units concerns their foundations and anchorage on the seabed. In this case, resolved foundation structures are required. For this reason, we have developed the tripod foundation structure. Bremerhaven provides ideal conditions for both our future serious production of tripod foundation structures and their transport by ship. In one of the biggest seaports in the world, we have optimal infrastructure and superstructure, direct access to the railway network, a nearby motorway, and our direct harbor site with key facilities. Before beginning serious production, the construction of a prototype is essential. Through this, we gain experience in the areas of assembly and in the manufacturing process. Bremerhaven, as a wind energy center, is our location for the first offshore wind energy installation worldwide with an offshore tripod foundation. The multi-breed M5000, with its output of 5 MW, has been operational since the 22nd of December 2006 and is being tested on land. With this construction, WeserWind GmbH Offshore Construction Georgsmarienhütte has successfully taken an important step forward towards operations in deep waters. When operating in depth ranging from 25 to 35 meters, up to 1,200 tons of steel have to withstand the forces of nature. To meet this challenge, WeserWind has laid the foundations, the tripod foundation structure. The tripod project was prepared and managed from here in the Offshore Construction Center, the WeserWind headquarters, whereas OWT, Offshore Wind Technologie GmbH from Leer, undertook the engineering of the tripod. The complete tripod project was controlled and coordinated by project leader and his team. The result is the minimization of the materials used and a long service life. And this is what the enhanced steel construction looks like. First of all, 3 pile guides are put up, each with a weight of 35 tons. Then the 2 parts of the 215-ton center column are erected. Afterwards, the 3 lower bracings of 20 tons each are heaved into place, and finally the 45 tons top bracings are fitted. Including the first tower section, the tripod near the road Grauwallring is approximately 47 meters high and 600 tons in weight and was developed for an operational depth of 30 meters. For operations offshore, an even heavier weight is planned in order to withstand the pressure of the waves. As a subsidiary of the IAG, Industrieanlagenbau Georgsmarienhütte GmbH, WeserWind can fall back on a traditional company within the steel industry. In the main IAG works, the pile guides for the steel construction are produced. These alone, with a height of 9 meters, are about as high as a family house and have a diameter of almost 3 meters. Each pile guide weighs about 35 tons. By using an automated, computer-controlled flame cutting technique, the top and lower bracing profiles are cut to size. These constitute the connections to the pile guides and the center column. The challenge consists here in precisely working the welding seam so that its angle is constant over the complete profile. A later correction is almost impossible. The smallest differences in the end measurements of each component are detected. The experts from the Fraunhofer Center für Windenergie und Meerestechnik (CWMT) take over the analysis of the survey work. A so-called best fit analysis is undertaken. In this case, it is basically about determining the best fitting joints for the specified assembly positions. This is done using a mathematical algorithm. In addition, simulated production times are determined using new computer production control systems. The construction management tool allows a simple and clearly presented view of the logistics. This software makes sure that the individual matching components, which result from the best fit analysis, arrive at the corresponding site. Whether by ship or by truck, the construction management tool shows where each component currently is. In this way, more than 800 tons of steel arrive at the specified site. Regarding series production, these processes help reduce production times. First of all, the pile guides are positioned and then aligned exactly on top of the prepared foundation on 3 plates. Afterwards, the center column upper and lower sections are erected.
Müssen wir uns irgendwie für Mittel entscheiden. Haben wir jetzt etwas Widerstand. Stefan, jetzt ist er top. Wir weisen uns hier am Blech auf und fahren den dagegen. Dir hin. Ja, gedreht werden muss er nach meinem Riss zu dir.
Erecting this construction is precision work. Therefore, all parts are once again measured and the results compared to those from the first best fit analysis. Only after a renewed check of the best fit results are the items released for assembly. The bracings, which are produced using the most modern computer technology, are lifted into their specific assembly positions. This maneuver means precision work for the crane driver. Because welding the complex profiles is very costly and challenging, the workers revert to proven automatic technology. The aim is to automate the assembly and welding operations as far as possible. In this way, the production period and costs are minimized and the quality of the weld seams optimized. Besides submerged arc welding on large section thicknesses, other new application-specific production processes in the area of welding technology are employed. An automatic submerged arc welding machine is used on the center column. First of all, the sheet metal must be preheated. Because the welding is done horizontally, special technical procedures are required in order to prevent the powder from sprinkling down. The automatic submerged arc welding machine has to loop the tower many times until the required welding seam volume has been produced. The welding controller carefully supervises the welding process and readjusts the given parameters where necessary. After welding has been completed and all the weld seams have been checked, corrosion protection can be applied. For this, the complete tripod construction is covered up. On the one hand, this guarantees protection for the immediate surroundings from sandblasted material and paint spray. On the other hand, wind is kept away from the structure while paint is being applied. Once the coating has been applied, the assembly of the remaining tower sections can begin. One of the biggest mobile cranes in the world is required for this assembly. This crane can lift up to 1,500 tons. The lowest tower section is welded to the tripod as no bolted or flanged joints are allowed here. There is a reason for this. When offshore, this point is at sea level. A flanged joint would not be suitable here because of the aggressive nature of salt water. Corrosion and water penetration would result. After several years of project development as well as several months of assembly work, the Multibrid Entwicklungsgesellschaft mbH from Bremerhaven and WeserWind GmbH Offshore Construction Georgsmarienhütte can complete the project. Since the beginning of December 2006, the Multibrid M5000 turbine and its rotor spider have been mounted on the first prototype tripod worldwide. The unit is ready to go. Sigmar Gabriel, the German Federal Minister of the Environment, was visibly impressed by its construction and, together with other high-ranking political representatives, officially put the unit into operation. The first German wind park out at sea is due to be set up in 2008. Here, out at sea, the tripod structure is anchored to the seafloor using 3 tubular steel piles. These piles are rammed up to 40 meters deep into the seabed and jut out to about 10 meters above the seafloor. The tripod, with its pile guides, is brought over these tubular piles. The resulting gap between the tubular steel piles and the pile guide